Welcome to all. Today I am going to discuss in undergraduate electronics lab experiment number 2. Design of half order, full order, subtractor and full subtractor using logic gates. In that first experiment is half order using basic logic gates. Half order means it performs the addition operation. It has two input A, B and similarly two output. One is sum, another is carry. A is input, B is another input means. I am going to use XOR gate 8 IC7486. XOR gate performs the sum operation, sum equal to A XOR B. Another one gate is AND gate 7408. Our carry is, as per the expression, carry equal to AB. We are going to give the multiplication operation with the help of IC7408, that is AND gate. Now I am going to verify the truth table of half order. Two input A is 0, B is 0 means output, that is sum equal to 0, carry equal to 1. Next input is 0, 1. Here sum equal to 1, carry is equal to 0. Next input is 1, 0. Sum is 1, carry is 0. Both inputs are 1 means A1, B1. Sum will be 0, carry is 1. Okay, next, I am going to explain the connection diagram of half order. IC7486 has two input, 1 and 2, 3 is the output. From one input is given to pin number 1, second input is given to pin number 2. The sum will be A XOR B. Similarly, I am going to give the input for the AND gate. From the terminal 1 or from the pin number 1 of IC7486, we want to give the 740, that is AND gate input number 1. Similarly, second input is given to the pin number of IC7408. Here 3 is the output, carry is the output, A, that's equal to AB, multiplication of input A and B. Next I am going to implement and verify the truth table of half order using the basic logic gates. In this first one is IC7486, this is XOR gate. It has two input here. One is the input and one more input is 2 is the input, that is A, B is the input. I am giving the input pin number 1 and 2. Next output is 3. That is sum is taken from the pin number 3, output is 3. We want to give the VCC in the 14th pin and the ground signal to the 7th pin. Next, the output of carry can be obtained with the help of AND gate. AND gate, it has two input A and B. From the IC7486 pin number 1, I am going to connect the IC7408 pin number 1. Similarly, 2 and 2 is connected between the two IC. Additionally, we want to give the 14th pin is VCC and another pin is 7th pin is ground. The output terminal is taken from the pin number 3. That is a carry output, C equal to AB. Next, I am going to verify the truth table using the input. Here both input are in 0 value, that is low value 1 and 2, that is AB equal to 0 means. Output also 0. From the truth table, output also 0. Next, I am going to modify the input from 0, A is 0, B equal to 1. In this case, input 0, 1 means, that is sum equal to 1, carry equal to 0. Next is 1, 0. Input is A1, B equal to 0. Sum is 1, carry equal to 0. Next, both input are high, that is value is 1 means sum will be 0, carry is 1. From this implementation, I verified the truth table using basic logic gates. Next, I am going to explain the half order using the basic NAND gate only. In this case, I am going to replace the IC7486 with the help of NAND gate. It consists of 4 NAND gate. And for carry purpose, I am going to use one more NAND gate. Totally we want for 5 NAND gates. In this operation, 4 NAND gate from one IC, another NAND gate for second IC. This is input A, that is given to the pin number 1 of 7400. So another input is given to the pin number 2. So the output is taken from the pin number 3. So this is given to pin number 5 and also pin number 9. Otherwise you want to short the pin number 5 and 9. So and give the output of 3 to the pin number 5 or either 9. So for second gate, so input is fourth pin is connected to the first pin of 7400. Similarly, 10th pin is connected to second pin of first gate. So here 4 and 5 are the input, 6 is the output, 9 and 10 is the input, 8 is the output. So second gate output is given to the third gate 12th pin. So 8th pin output is given to the 13th pin. So finally we get the output sum A XOR B in 11th pin. So for carry purpose, so we want to use another 7400 IC. So two inputs. So we want to short 1 and 2 shorted. So I am going to give the input from the first IC pin number 3. So pin number 3 is connected to the shorted pin number 1 and 2 in the second IC 7400. So here carry is equal to AB, multiplication of AB. So this is the truth table of half order. So here two input, A, B is the input, sum is the output and carry also output. So input is 0, 0 means output is 0, 0. Input is 0, 1 means sum will be 1, carry is 0. Input is 1, 0 means sum will be 1, carry is 0. So both inputs are 1, 1 means sum will be 0 and carry is equal to 1. Next, I am going to verify the truth table of half order using basic non-AND gate. So in digital trainer gate, so connections are made as per the circuit diagram already explained before. So here we are using the two ICs. So first IC output is given to the second IC. The one IC used for the sum, another IC used for carry. So now I am going to verify the truth table as per the circuit diagram. As per the table here. So input is 0, 0 means output also, that is sum is 0, carry is 0. So I am going to apply the input 0 and 0. So here output is 0 and 0. So next input I am going to modify the input. So 0, 1. So A is 0, B is 1. So now output is 1, that is sum is 1, carry is 0. So next input is 1, 0. So input is 1, 0 means sum equal to 1, carry is equal to 0. So last input is both input are high value, that is 1 means sum becomes 0 and carry becomes 1. So with the help of the two NAND gate, so I am going to verify the truth table of, half order. So input is A and B, two input, output is sum and carry. So that's all about the implementation of half order using digital training was completed. Okay, next I am going to explain the half order using XOR using basic gates. So this is the half order circuit. So it has two input, 1 and 2. So A is the input, B is the output. Two output is, so one is the difference, D is the difference, A XOR B, another one is borrow. So it has two input, A and B, and two output, one is the difference, another one is the borrow. So here I am using the IC 7486 XOR gate and one NOT gate IC 7404 and one AND gate 7408. So input 1 is given to XOR gate pin number 1, 2 also given to XOR gate pin number 2. So output is taken from pin number 3. This is difference A XOR B. So next from input 1 is applied to the NOT gate of pin number 1. NOT gate output is taken to the pin number 2. So that is given to the input for the pin number 1 of AND gate, and input 2 is directly given to the input of pin number 2 of AND gate. So it is 7408. So finally we get the output from the third pin of AND gate, that is borrow. Borrow is equal to A bar B. So subtractor, so it performs the difference of two binary inputs. So this is the truth table of of subtractor. So A and B is the input. 0 0 means so difference also 0, borrow also 0. So 0 1 means so difference is 1, borrow is 1. So 1 0 means difference is 1, borrow is 0. 1 1 means difference is 0, borrow is 0. So this is the truth table. So using this digital trainer case, I am going to verify the truth table of hop subtractor using XOR gate. So here we are using the three ICs. So one is IC 7486. This is XOR gate. This is NOT gate 7404. This is AND gate for 7408. So input is given to the pin number 1 of XOR gate. This is pin number 1. This is pin number 2. Input 2 is given to pin number 2. So output is taken from the pin number 3. This is output port. So difference is equal to A XOR B. So output is difference equal to A XOR B. This is pin number 3. So 14th pin is VCC. 7th pin is ground. Similarly, we need to give the VCC supply and ground supply to the another two ICs also. So this is NOT gate. So from the pin number 1 of XOR gate is inverted into using the NOT gate. So output of the pin number 2 is given to the AND gate 7408. So from the AND gate the output is taken from, this is the borrow output, that is A bar B. So finally all the connections are made as per the circuit diagram. So now I am going to apply the input signal and verify the truth table. So using this trainer kit. So 0 0 is the input, 0 is A, 0 is B, means both input are 0 0 means difference also 0, borrow is 0. So 0 1 means so difference is 1, borrow is 1 as per the truth table. Next is 1 0 means so difference is 0, borrow it, sorry, difference is 1, borrow is 0. So both values are 1 means, that is high means difference is 0, borrow is 0. So from this digital trainer kit and this experiment I am verifying the truth table of hop subtractor using the XOR gate. So input is 0 0 means difference is 0, borrow is 0. 0 1 means difference is 1, borrow is 1. 1 0 means difference is 1, borrow is 0. 1 1 means both output are 0. So from this guarded implementation I verified the truth table. So this is a circuit diagram for hop subtractor using only NAND gate. So I am going to use the NAND gate to design the hop subtractor. So in previous diagram, so in this XOR gate 7486 is replaced by 4 NAND gates. So this is IC 7400. So it is a 14 pin IC. So for particular IC it has 4 NAND gate and we are using another IC for the borrow output, that is 740. So initially input 1 is given to the first gate of 7400. Pin number 1 is input, 2 is the input A. So output is taken from pin number 3. So same input 1 is given to the port number, that is pin number 4, and 2 is given to the pin number of 10 of another gates. Here 5 and 9 pin number is short circuited. So output of first gate is given to the pin number 5 or either 9. So gate 2 output is taken from 6th pin, that is given to the, so next gate is pin number of 12. Gate is, it is taken from the output is taken from the third gate and it is given to the fourth gate of pin number 13. So finally we get the output from the 11th pin, D is equal to A XOR B. This is the difference. So for borrow output, so we need to connect, so another NAND gate for pin number 1 and 2 is short circuited. So output of previous first gate number, pin number is 8 is given to the input for the this NAND gate. Pin number 1 and 2 already short circuited, either 1 or 2. So output is taken from the third pin, borrow, that is equal to A bar B. So this is the truth table for hop subtractor using NAND gate. So input is A and B, in both input are A, and A is 0, B is 0 means difference also 0, borrow also 0. So A is 1, B is 1 means difference is 1, borrow also 1. So 1 0 means difference 1, borrow is 0. 1 1 means difference is 0, borrow is 0. So next, so I am going to verify the truth table using the digital trainer kit. So this is a digital trainer gate. We give the input and VCC power supply and ground signal using this trainer gate to the IC. Here two ICs are used. So one NAND gate and this is another NAND gate. So input is taken from the input port. Input is pin given to the pin number 1 and another input is given to pin number 2. So difference output is taken from the pin number 11. So all the connections are made as per the circuit diagram explained already. So 14th pin is VCC, 7th pin is ground. So this is a second NAND gate. So 14 pin VCC, 7th pin is ground. So output of pin number 8 of first NAND gate is given to the input for both 1 and 2 because 1 and 2 already short circuited. So output 3 is taken from the second IC pin number 3. So this is borrow. So A bar, B is the borrow. So if the both input are now input is 0 0 means output also 0 0. So input is 0 1 means difference is 0, borrow is difference is 1, borrow is 1. So input is 1 0 means so difference is 1, borrow is 0. So if both inputs are I mean that is 1 1 means so output is difference 0, borrow is 0. That's why using this digital trainer gate. So I am verifying this truth table. Input A 0, B 0 means difference 0, borrow 0. 0 1 means 1 1. 1 0 means 1 0. 1 1 means 0 0.